But our first presenter is Wes Bos. He's somebody I've gotten to know a bit over the last few years. He's just coming right up here on stage, so I'm just gonna say like really awkwardly nice things while you're standing right here next to me, which is just fine. But he's kind of a hometown guy from right around here. He's been doing this kind of thing around the Toronto area for a really long time.
12 years at this conference alone, I think.
But you have taught, I would venture to say, maybe not millions, but an awful lot of people have watched your videos.
Dozens.
There's at least like 12, 15?
At least
is that? Okay,
dozens,
cool.
Yeah.
But you also, he just is a lover of the open source community, dedicated to teaching other people how to fish. Or more accurately code, I guess, but that's not a good metaphor, really. But I just wanted to also highlight the work that you've done helping people who might sometimes have a harder time breaking into this industry, and those groups like Ladies Learning Code and HackerU, you've opened the doors to a lot of people. It should not be understated what a pillar of the community you really are. It's an honor to present Wes Bos.
Awesome. Thank you. Awesome. Hey everybody, thank you so much for coming out. I'm pretty stoked about this talk. My talk is called Next Gen Server-Side JavaScript. My name is, to exit full screen. Okay, there we go. My name is Wes Bos. I'm from Hamilton. I live in Toronto for about 10 years, so I'm kind of from around here. I'm at Wes Bos on all of the social medias if you'd like to catch up with me and see. I'm posting tips and stuff and whatever's going on with JavaScript, HTML, CSS. I'm a full-stack JavaScript developer. I make a whole bunch of web development courses around Node and React and CSS, things like that. I also have a podcast called Syntax, which, has anyone ever listened to the podcast or taken one of the courses? Yeah, right on. Cool. So you can check that on out. But this talk here, this talk is about server-side JavaScript, specifically around JavaScript runtimes and sort of a new breed of tooling that has sort of cropped up around these new JavaScript runtimes. So a JavaScript runtime is an engine and a whole bunch of APIs added on top of that engine, and those things together make what's called a runtime. Which, so let's look at the engines, right? We have three main engines. There's lots of them out there, but the three big ones are like V8, which runs Chrome and Edge and all the Chromium, which is like PlayStation browser, things like that. There's SpiderMonkey, which runs Firefox, and you have JavaScript Core, which is inside of Safari. So when we're talking about runtimes, Node.js is a runtime, and that runs on the V8 engine, right? And then we have Dino, which also runs on V8. We have Cloudflare Workers, which also has a V8 core, which I realized, yeah, take a picture, send it to your boss. I didn't realize the Cloudflare guys were here today. We have Bun, which took the engine out of Safari and is now running a server runtime with it. Fastly Compute at Edge runs on SpiderMonkey. Alibaba runs on V8. Amazon is coming up with their own JavaScript runtime on this thing called Quick.js. It's experimental. It's not really in the same things as this, but they're still working on it, right? It's actually pretty nifty. Bloomberg has their own. TikTok has their own JavaScript engine, which is wild, sort of behind the scenes. So if my math is correct, we have like kind of like three browsers we kind of have to support and test out, right? Hopefully 3 for a little while. But we have like 6, 7, 8 JavaScript runtimes. This seems a little bit nuts, doesn't it? And you're probably thinking to yourself, like, can this all just stop? Like, I'm stressed out enough. I don't need this many runtimes to have to support. We're going to end up with Internet Explorer again, where we have to support all these stupid runtimes, and it's a pain in my ass, right? So I'm here today to tell you that the next generation of server JavaScript is the stuff that we write is going to be standards-based, and you're not going to be having the IE6 all over again. So yes, like this is going to be running everywhere, but what I'm really excited about and what I'm here to talk to you today about is that the ecosystem is a large amount of interchangeable and composable layers. So should you care about all of these different JavaScript runtimes, or should you just stick with Node, right? Maybe. And what I'm here today is I'm going to tell you, you should probably care about the standards and about the code that we are writing from today forward is going to look a little bit different than the code that you maybe have written in Node for the past 10 years. So let's talk about why. Why do we have so many runtimes? Why isn't one enough? Can't they just pull request Node and make it better? That's what everybody says. So first of all, they're better. A lot of them have TypeScript out of the box. A lot of them are pushing Node added TypeScript out of the box in the latest version 22, which is pretty amazing, right? We have a push for standard APIs. They're all built on the ECMAScript module spec. You have a lot of easy wins, like TypeScript is easy win, .env just works. You don't have to install a package. You have prompts. A lot of them support JSX out of the box, which is pretty nice, wherein you can just use something and not have to install a million packages for it. And quite honestly, it's just a joy to work with. Next benefit, faster. I'm not here today to tell you about a whole bunch of like amazing stats and charts and whatnot, because quite honestly, that's not my wheelhouse. But what I do know about these things being faster is that there are a lot of very big companies that spend millions of dollars on infrastructure, and yes, they are concerned about them being faster in the fact that like your website loads faster, but there also is this whole area of, can we shave 20% off our $4 million AWS bill? And that's a major, major gain for them, right? So also, at scale, it's a lot cheaper. A lot of them are starting to look at this thing. Cloudflare is probably the biggest one where they bill based on what's called CPU time and not wall time, meaning that you have like a function that runs on the server, and it's pretty big in AI right now. You generate an AI prompt, and then you send it off to your AI model, and then you're sitting around waiting for 2 or 3 seconds, and then it comes back. With a lot of these serverless, you're paying for those like 4 seconds, where some of them now are saying, well, you shouldn't have to pay for just like waiting around for a fetch request, so you're only paying based on actual compute. Stronger. So Dino, built by Ryan Dahl, creator of Node.js, out of the box, it's kind of like your computer, where you have to approve every single thing that goes through, which is kind of a good idea if you think about all the random scripts we're running from random people on the internet, and these banking applications are built on Node modules that some dude in Iowa wrote. It's kind of a security flaw, right? So this will allow you to, can I have access to disk? Can I have access to your environment? Can I access the network? What domains is it allowed to send data to? So let's talk about server kinds. The first one we have here is your traditional VM long-running server. So this is, you go to DigitalOcean or whatever, you just grab a box or Hetzner or whatever, $5 a month, you're running your server, it's always running, it maintains memory. You can scale them up by giving them more memory, more CPU, or you can scale them up by simply just getting more servers, and then you load balance your application between the two. Then we have serverless functions, which I know they're still servers. We've heard that joke, you can stop saying it. They only run in like short bursts as you need them, right? If you need to scale up, you simply just run more of them, and then you sort of pay for what you need. So if you have a billing thing that generates a whole bunch of PDFs once a month, you can only run those once a month rather than paying for that server all month long. Now we have edge functions, which is kind of blurring the lines. The Cloudflare people don't like when we call it edge functions. They run closer to your user. They can run in between or intercept requests, which is kind of cool. I'll talk about some use cases. Limited API, I crossed that out because there's some stuff I'm going to talk about in just a sec. And generally, at least right now, they're not 100% Node compatible, but we're getting pretty close. So what are we supposed to do? Are we supposed to support 6 different runtimes? Yes, but also no. Nobody wants to do that. That's a pain in the butt. No, not a lot of people are actually going to do that because We got much better stuff to do with our time. And the answer that we have here is JavaScript. So we have kind of 3 standards bodies right now. We have TC39, which is responsible for, like, what does JavaScript look like? Async await, variables, functions, scoping, how all of that stuff works. That's decided in TC39. And then we have the W3C, which is responsible for WebRTC, the Streams API, web components, things like that. And then we have the WET working group, which is responsible for resize observer, service workers, fetch, kind of stuff like that, right? And how many of you have installed Node Fetch before or have done it, right? Probably all of you have installed it this morning because it has 45 million downloads per week, right? It's quite a bit. And you might be asking yourself, like, why do we have Node Fetch? Why does that exist? And that's because Fetch was a browser API. It wasn't a server API. And a lot of people don't understand that. They're like, oh, Fetch is part of JavaScript. Why is it not in Node? Why do we have to install this isomorphic Fetch thing that runs in Node? So we have this new kind of working group called the Winter CG, and it's made up of all of those companies that we talked about. And they are responsible for making sure that these APIs are sort of standardized and run absolutely everywhere. So we're not having these weird things. So browser.js is server.js. Server.js is browser.js. JavaScript is JavaScript, right? We don't need different ways to do the same thing in most cases. Sometimes, yeah, there's a specific server API because you can only do that in the server. But as long as we can, as much as we can, it should be the same across all of these different runtimes. So let's look at a couple of them. Probably the biggest one is Fetch. A lot of these web servers, or all of these web servers, are built on Fetch and its 2 big pieces, which is web requests and web responses. So in the browser, when you want to send a request, obviously you can just pass the URL to Fetch, but this is what's happening under the scenes, is you create a new request, then you pass that thing to Fetch, and then what you get back is called a response, right? So you have a request, a web request, and a web response, and that is your sort of 2 building blocks of the web. Now you move over to the server, you have an event handler, somebody hits a URL, you're going to get a request coming in, and then you return a response, right? Those are the same things both in the browser and the server. So I took a look at this little piece of code. So this right here is a request and response piece of code that's coming in. And that one piece of code will run in absolutely every runtime here. It will run in Dino, it will run in Node, it will run in Bun, and it runs in Worker D, which is what Cloudflare runs on. And that's pretty cool that we've sort of standardized what does a event handler look like across all these platforms. So in Node, it's not native, but there are lots of packages that will allow you to have this API. I'm going to talk about a couple in an upcoming slide. The next API is web streams. Blow chunks as you got them. So web streams allow you to send data from the server to the client even before you're done computing it on the server. And that's pretty cool, especially you've all used ChatGPT or whatever, and you see ChatGPT putting the words on the screen as it comes in, and a lot of people are like, cute trick, like all you're doing is looping over it and writing each word. And no, what's actually happening is as the model is computing the words that it's going to give you, it's putting them out the door. I'm not sure I'm done yet, but I'm sending them to the browser right away, and the browser can start rendering them even before the server is even done making the pie. Abort controller. So this is client-side code here. And if you want to cancel a request, you create what's called an abort controller. And you simply just call controller.abort. And that will tell the server, I no longer want this request. Then on the server, you simply, when you are creating a stream, this is a readable stream. There's several different kinds of streams that you can use. In this case, we just have a cancel method that when somebody calls abort from the client side, the cancel method on the server is going to run, right? That's standard. There's no like layers to add there. There's no extra work. There's no APIs to add. It simply is all just connected. We're starting to see this in all of our frameworks, in React and Svelte and Vue and everything like that, where you're able to start sending your HTML that is rendered on the server to the browser before it's even done rendering all of the HTML, which is pretty cool. Events. This one is kind of cool. This piece of code here, global this.addEventListenerLoad, will work on the browser or on the server. So in all cases, the syntax for listening to events is the same, and in some cases, the events are even the same. So this is kind of cool because you can create custom events that you could fire off and then go ahead and listen for. So if you have like an application that has something like for example, when you take an Uber and your ride is over, it'll like pop up an event that says like ride over, and then anybody else in the application can listen for that event and show some UI on the screen. Form data. So anybody use Remix in here? Anyone use React Server Components in here? A couple people. So form data is a browser primitive and now a server primitive that is for basically taking a form and structuring it in object format. And there's all kinds of really nice methods on it for managing your form data. You can actually take an HTML form and turn it into a form data object. And that's really nifty because you can collect your data in the client, send it to the server, and that format is well known. And this is how Remix is working. This is how React Server Components is working. This is how Svelte works. Being able to pass data from the client to the server is all done in the standard format of form data. Web workers. So you want to be able to do multi-threaded, parallel, CPU-intensive tasks. It's non-blocking. If you want to be able to do work with that, because everyone says, yeah, JavaScript is not multi-threaded. It can be, right? It's not just, yeah, async await is concurrent, but if you actually want them to run in parallel, you can throw it in a web worker and have that. And that, again, that works everywhere. Alert prompt confirm. This one's kind of silly, but I thought I would put it in there just to illustrate my point. This code right here, alert, a prompt, confirm, and then a console log with some CSS to actually run it, that runs in Dino, where it will alert you, prompt you, and then allow you to confirm something, and then console log with those specific colors. And again, that's kind of silly. Maybe you're building a CLI app or whatever, but it just illustrates my point of how you could take this code and run it in the browser or on the server, and it still works. Sync local storage. I'm really excited about this one. So async local storage solves the problem of being able to pass data from one function call to another without having to pass it via parameters. So when, let's say, for example, you're writing a server endpoint and somebody visits like /show/2, you might have one function that parses the URL, and then you run another function that looks it up in the database. And you might be 6 or 7 function level calls deep before you actually send your response. And if you want to be able to pass data about the request into each of those function calls, you usually have to go modify your function, set up a parameter, and pass that data in, which is usually what you should do. You should usually have parameters that your functions take in the data, right? Because then your functions are nice and pure. However, sometimes it's a bit of a pain in the butt to have to hot potato this data from function to function to function every single time. So what async local storage will do is you can create a data store, and any functions that are called down the call stack, so anything else that calls within that single scope will be able to access that store. So here I have one that creates a new store with an ID. And then 1 calls 2, and then 2, after a random amount of seconds, will call 3, and then 3 is now able to access the data that was created in 1 without having to hot potato pass it via arguments. So that's really useful for IDs, user data, requests. Anyone use Express in here? So in Express, what we often do is you'll stick it on the request, and then you have like a middleware, and the middleware needs to access that data. So you'll stick it on the request and then access it on the request. Now you can put it in async local storage, and it's available to you everywhere. It's used in Next.js to get cookies and headers and all kinds of neat stuff without having to explicitly pass them in. So async local storage is a Node API, and Dino will polyfill all of the Node APIs. But Ryan Dahl says, like, I worry about adding a browser incompatible API, which just goes to show his stance on creating server APIs. Is there any hope of async local storage in the browser? And yes, we're going to get something called async context. It's actually in stage 2 now. So I bet probably a year or so we're going to be able to have this standardized JavaScript API. And then the async local storage will probably go away. It's also a bad name because it's not local storage. It's not. It has nothing to do with like the browser local storage that you're used to. Now, let's talk about the developer ecosystem. The tooling is standardizing on standards. So I wrote that, and I was like, that's a dumb sentence. But then I was like, that's kind of what it is. So there's this movement called UnJS, or Unified JS, which is a collection of tools and packages and utilities that will work anywhere. Will work together. See the puzzle pieces? They work together. Do you understand? And they'll work across all these platforms. So first one is unenv. So the other day, Cloudflare announced that most of the Node APIs now work in Cloudflare workers. And I was like, holy smokes. Like they put a chart up. It's like 97% or something like that. You go to the Cloudflare guys and talk to about it. I was like, wow, that's really cool. I wonder how they did that, because they have been polyfilling and writing their equivalent of the Node APIs out there. Because as much as I'm here yelling standards, 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 the reality is a lot of our software is built with Node APIs. And kind of the Node APIs is kind of the standard. You know, a lot of people use it. So this package called unenv basically polyfills all of the rest of the Node APIs so that it will run absolutely everywhere. It works pretty simply. You just take your code, you can pass in the platforms that you want to support, and it will do the polyfilling, much like you would in the browser when the browser doesn't support a feature just yet. Let's talk about web frameworks, right? So two big ones right now, Hono.js and Nitro. And these are, you can kind of think of them as Express.js of the next generation. So Express.js, huge web server right now, but if you are building something new right now, you don't want to be building on Express, you want to be building on web request and web response, right? The whole fetch API that I just told you. And these frameworks right here will give you things like, oh no, I went too far. Here we go. They'll give you things like hot module reloading on the server, routing, middleware, caching, WebSockets, assets, all the stuff that you're used to. Because like, as much as I love that example that I gave you that ran absolutely anywhere, the reality is you probably do want a framework that has a bunch of nice little utilities, right? You can return JSON and not have to set the headers on it. 5 minutes, we can do it. H3 is a framework for that actually runs under the hood of Nitro. So Nitro uses H3. H3 uses this thing called Cervix, which is not released just yet, but I got permission to share it. This is like a very low-level request response framework for a web server for handling them. It doesn't have any of the nice utilities. So you're probably not going to be using Cervix. You're probably not going to be using H3 directly. You're probably going to be using Nitro or Hono, which is your kind of top-level web server with the nice APIs. Oh my gosh, sorry, my sticky thing here. Now, we also have this thing called Vinci, which will take Vite. So Vite is a browser dev tool that allows you to build You can build React apps with it. You can build Vue apps. You can build anything with it. It does hot reloading. It does CSS. It does all of your bundling. This slide deck for you here is running on Vite Dev Server right now. And it's a really nice developer experience. However, the thing is that people build these Vite apps and they go, oh, I need a server. I need an API endpoint. What do I do? Vite doesn't really have that, right? So Vinci is Vite for the client, Nitro for the server. Those two things together are called Vinci. And essentially allows you to build your own framework. So you take any JavaScript library that you like, right? You can take React or whatever, and then you can take Nitro, which is the server, and those two things together, you can essentially make your own meta framework. You can make your own Next.js. So two big projects right now are actually working on this. TanStack Start, which anyone use any of the TanStack stuff in the past? Only a couple of you. So TanStack has two really big packages. They have a router, and they have this thing called TanStack Query, which is a really popular way to do state management, loading, fetching data from the server. And that's been great, but a lot of people are like, well, I want like a remix, or I want a Next.js. I want a full stack framework in order to build my thing. And same with Solid. Solid.js is a React-like, many will say much better than React library for building reactive interfaces. And Solid Start is the full stack framework that you can do back end and front end. So these full stack frameworks give you things like routing. They give you RPC, which is the ability to call server code from the client without having to make an API. So if you want to pull in a list of shows, or you want to add a to-do item, you want to delete something, you want to like something, normally you would make like a whole API endpoint every time you want to do that and then fetch to it. RPC will allow you to simply just call that function from the client on the server. They give you data loaders, middleware, API endpoints, server-side rendering, client-side hydration, streaming, caching, a whole bunch of stuff, which is, if you don't have like a whole separate API backend server, that might be what you want. And you're doing it all in JavaScript, right? You just want a full stack framework to be able to do that. This might be what you want, right? So TanStack Start is Vite, TanStack Query, TanStack Router on the client. And then on the server, it uses Vinci, which Vinci uses Nitro, which uses H3, which uses Cervix, which is like, you don't have to worry. I'm telling you what it is, but like, don't get stressed out. Just know that you can just use these things with not having to worry about it. Why I'm telling you about this is that there are these layers of amazing pieces of technology that people are building upon. And it's amazing to see that people are spending time at each layer creating these little building blocks that can be stacked up. One other one I like is a JS DOM alternative if you want to do DOM parsing. You guys will like this. I wrote a scraper for the Canadian Tire Deals website, and I parse out the price of each of the items from Canadian Tire, and you have to use like query selector or whatever, but you want to do that on the server, right? Because I want to find the best deals at Canadian Tire. So I parsed out the price with this package called LinkDOM, and it works everywhere, right? It works in the browser, it works on in a web worker, which doesn't have a DOM, and it works on all the servers. HTML rewriter, Cloudflare invented this, but it's been re-implemented anywhere, and it's kind of cool because you can put like an edge function in front of your application, and you can sort of stream the data coming in and replace attributes that you want. So you want to add a class, you want to add dark mode. In this case, is if you have a whole bunch of images that are running on your server, but you want to put a CDN in front of them, you can dynamically replace the URLs of all of the images on your page before it actually gets to the end user, right? You're sort of proxying your entire application, and HTML rewriter is a really nice API for morphing your HTML. There's so much more to this, which is really exciting, and it's not a write once, work anywhere, at least not yet, but it is a set of standardized APIs and an ecosystem full of really, really awesome tools that all work together. And I honestly think that these things are going to be becoming very popular in the next couple of years. So future JavaScript isn't about making it work everywhere. It's about building with standards and enjoying the huge ecosystem of the best tools, and then having the choice for it to be able to run everywhere. Thank you.
Thanks, Wes. That was great. A reminder, FITC.ca/ask, and you can post questions that I will then read. So go do that. Henri, how are you?
Questions, yeah.
Okay.
Are we sitting?
So,
yeah.
I think we're sitting. We're gonna have a nice, relaxed little chat for a few minutes, and I know some people are furiously writing away some questions they're going to submit. The first one I'd have to ask is if you're Canadian, is async supposed to be pronounced async?
Async.
I had to start with the joke. I had to. It's just.
I do have a joke that I invented called. When I was first announcing, not announcing, but when I gave a talk on async await, my slide was async and await, and nobody got it. But then they did get it when I explained it, and they thought it was really funny. And now I see the joke come up quite a bit, and I think like that's my legacy.
If for no other reason.
Yes.
That's okay. So I want to ask, in the way that you're describing these things, that the solution to the proliferation of JavaScript runtime engines is more JavaScript. I mean, I get it. I get where you went with that, but it does sound like a little bit of a pile-on. How do you feel that is impacting performance for the end user?
It's honestly better because the people that build these engines bicker with each other and hate that they all post graphs about which one can do. Like last night there was some stuff. Dino 2 came out yesterday and they said it was faster than Bun, and then Bun came out with a whole bunch of things that no, we can do 20 million requests per second, and it's like, I have not needed to ever do 20 million requests per second. That's quite a bit, you know? So honestly, it's good. They all are battling each other on who can be the biggest perf one. And then, like I said, there's also big companies that have millions of dollars in infrastructure bills that, like, so Amazon is working on LLRT, which is built on Quick.js, and they are simply doing it because they have people that run functions that is costing them millions of dollars. And if they can bring that function down by 50%, imagine saving your company $500,000 on server bills. That would be huge.
It actually reminds me of some work that I did with Redspace a few years ago, moving a broadcast platform over to variable fonts in their streaming platform, reduced their streaming by a couple of terabytes a year. And I think that's sort of an interesting thing when you're talking about the being able to start to pipe things out. I'm also on the web font working group at the W3C, and we're working on incremental font downloading. And that's something that, again, is allowing you to do things bit by bit as it's happening.
Yeah.
So is that, that seems like a common thread about being able to do things without, I mean, two of the biggest blockers, JavaScript and fonts, in terms of like getting things on screen. Is this kind of our way forward?
I think so, especially like when you can send parts of the website that are ready to the thing. Like obviously it'd be ideal to just cache the whole HTML page and serve it up in 3 milliseconds, and that's probably your first bet. But there are cases where you do want to stream it, especially with we're using all these AI agents that are taking it takes 15 seconds sometimes to return like an image that is being generated, right? If you can stream part of it or a lower quality version of that, that would be huge. Or even simply just like server sent events is a version of streaming, you know, and you'll be able to say, all right, I'm working on this thing, I'm 20% done. That's awesome to be able to tell the user that you're 20% done rather than just put a spinner there and they're not sure is it working? Do I need to refresh the page?
And how do you feel that could impact in the way we think about building? So if we, if we think about knowing this capability is here, designing in a way that the UI is a little bit more pluggable and modular that way.
I honestly think the frameworks take care of most of it for you. I don't think that most people in this room would have to think about it. And then when you do have to think about it, it's just like, oh, I have this problem. It's taking too long. And, streaming maybe is a solution in that case.
I want to get to some of the questions that have been coming in here. And one, I think, I would like to know what your beef is with people in Iowa, but I want to move past that because that seemed a little personal.
No, I'm a big fan of Iowa. I just, there's people on the internet doing bad things in node modules, and to be aware of it.
Well, actually, jumping off that, Sergey's asking about how do we ensure that companies don't keep doing their own thing, that they start to move towards standards. How do you feel we're doing with that?
Good. I think there's like a mix between like guys like me that are like everything new and it's exciting and standards, and then like companies that are like, we have 200 devs writing an Express app and it's working fine for us, you know. But I think what starts to happen is the devs go, oh, we want to use this thing, but we're not on that ecosystem, you know? We want to use these new cool tools, and we're not in that ecosystem, or we don't use the latest standards, so we're not able to use it. And at a certain point, like Common.js is another example, right? Like ESM everywhere is dreamland, but the reality is there's still a lot of Common.js out there. So either these tools or the runtimes also will make things easier for you, where you don't have to sort of sweat about that.
Well, I think that kind of leads into what's probably one of the last questions I think we'll have time for. But you've alluded to this a little bit. You know, this sort of a rapidly evolving sort of landscape with these things. How do you decide a safe framework, or to rephrase that, a safe way of working to leverage what's out there, but not feel like you're painting yourself or your company into a corner?
Yeah, I should have a slide on that. It's like the lock-in is scary, which is why I'm all big on this request response thing, because you take a function handler that runs in Next.js, you can move it over to like literally anything, and especially when you're using like a Hano or a Nitro, because they provide that if there are differences, they will polyfill it or give you a compatibility layer for that. And that's great, because when I build stuff, I want to know that I can duck out of it if I need to, and I'm not going to be specifically locked into it. Like probably the biggest lock-in that I have is that I write React and JSX. And a lot of the React APIs can move to other frameworks, and JSX works almost everywhere now. Even if you're not using React, lots of these frameworks are now just using JSX as a templating language. So I know, okay, like at a certain point you have to choose something, but can I get out of this if this goes south factor is really important to me.
Simon's asking the question about core.js. What do we do with it?
Core.js, that's like the polyfills of everything. Where Simon?
So that library, the author was like putting messages in the console and
Oh yeah. So the core.js was like, he's trying to get funding. Didn't he go to jail? Yeah, he went to jail. I don't know what to do about that. Yeah. Yeah, it's very, very heavily depended on, and I honestly don't know what the solution is to that. I think there's people working on, like Socket is a really good example. Like if you're talking about security, so Socket is a thing that scans every single node package ever, all the time, and has all these models to detect if they're doing something nefarious, and they can also run it and see. So like if something like that happens, then hopefully we know early, but like, didn't Linux have something sneak into Linux? Like, at a certain point, yeah, you have to know that this is kind of risky, but the world kind of runs on it.
Question swirling around a little bit about the availability of your slides.
Availability of my slides. Yes, they are on my GitHub. I'll tweet the link out after this for the slides as well.
For the knowledge and the hypnotic background pattern.
Yes. Ooh. Actually, view source on that background pattern because it's a canvas taking a screenshot 60 times a second, dumping it into a base 64 image, and then using that image as in CSS to mask over top of the text. Very cool. So not performant at all, but it looked okay.
I love just how massively overkill-y that is.
Mm-hmm. Yeah, that was a bit of a rabbit hole I went down.
All right, so I think that we had a little more time than I thought. So I want to cover a question that just came in. Advice for developers using JavaScript backends. Do you feel like that the same level of standardization support is coming there, or is it still staying pretty fractured?
JavaScript backends, like...
And if somebody is here who asked that question, if you want to elaborate.
Like server runtimes, that was the whole talk. Yeah, the standards are coming. Like we have the standards in the browser now, and everything's going great. And now we're trying to get it. And a lot of you might not even know, but like you're probably using a lot of these patterns already because these request response, this has been in like serverless functions for many, many years. And now the way to create a web server in any of these runtimes also uses that.
Awesome. So with the last minute or so, anything interesting coming up that you're working on that you want to tell anybody about?
Yeah. Well, so we have lots of really cool podcasts coming out. I think on Friday we have one with the author of TanStack Start, Tanner Lindsley. He's a really interesting, like he's one of those thinkers in the React ecosystem, right? And he questions everything, but also makes things easy. Like if you've never used any of the TanStack stuff, just try it out. You're like, oh wow, this is nice, you know? Wow, this is like if you've ever been frustrated at how odd some things are in React, certainly, especially Next.js. Like I'm a huge Next.js fan, but there's some funky stuff in there, right? And a lot of the TanStack stuff just makes it so simple. Bit of a breath of fresh air.
That's great. This has been awesome. Thank you, Wes, for starting us off.
Cool.
Thank you,
All right.
everybody,
Thanks,
for your
everybody.
questions.